G'day everyone, how you going? This video now is really, we've done a video on differentiation by first principles. Check that one out. I did a video with some simple questions, or relatively simple ones. Now what I want to do is kind of the harder questions, and I've picked two. They're from the very end of our textbook in this chapter. They're a little bit harder, but they're not really that much harder. What's harder is understanding what you're doing and why you're using certain parts. So don't try and remember these examples, but try and understand what I'm doing and why I'm doing it. That's going to help you a lot in your calculus type stuff, which is what this is. We're into calculus now. So we've got this here. You've seen this before, exactly the same as the last video. We need to find the equation of the tangent. Tangent, you're seeing that says I've got to differentiate. The tangent function or the gradient function is differentiation. Add those two words together. Find the equation of the tangent to the curve, this curve, at a particular point. Now you remember from the last video, the x value is the thing that I'm really interested in at the moment. That's the thing that's going to get me the gradient. Okay. So if I've got f of x equals 1 over x, then I can just rewrite it like this. Okay. Now I haven't done anything to that. That is still just f of x, but it's in a bit better format to here. Once you get better, you'll see what you're doing here. It won't be an issue. But for now, let's go with that. So then it's power out the front. So that's going to be a -1 out front. Lower the power by 1. X to the -2. But I'm going to write that on the bottom line. So it becomes x to the +2, doesn't it? Power out front. That's that there. Lower the power by 1. X to the -2 becomes that there. Okay, so I've got my derivative. Now I want to take my x value. This point, this whole coordinate, only links to the graph. But the x value I can put into my derivative function, my gradient function. So I'm going to say f dash of 1 is equal to -1 over 1 squared. 1 squared, just 1 anyway. -1 divided by 1, -1. So that's telling me that the gradient on this curve, when x equals 1, is equal to -1. What does -1 look like? It's a downward slope like this, isn't it? -1 going down to the right-hand side. So wherever that occurs on this graph, wherever this point occurs on this graph, the gradient is about like that, sloping down. Now, that's not the end of the question. See, that would have sorted us in the last video, but this is asking for the equation of the tangent. Tangents are always straight lines. So therefore I can say, well, y equals mx plus c. That's my equation of a straight line. And this is the gradient of that straight line. So put that one in. We've got y equals -1x plus c. Now this is where the whole point comes into play. Okay, the whole point. I put in my y value and I put in my x value and I work out my c value. So because it's 1 and 1, this is nice and easy. It's 1 equals -1 times 1 plus c. -1, move it over here, it's going to become +1. C's got to equal 2. Once I've got that, come back with this one, slot the c value in. I've got y equals -1x or -x plus 2. So that then is the equation of the tangent of this curve at that point. Now this question is a very, very common question. If you're doing a test on this sort of stuff, I guarantee you, there will be a question like this. It will say, work out the tangent at this point, given this curve, etc. Guaranteed. Guaranteed. Second question over here. This is a little bit trickier. This is a bit trickier. If you struggle on this, I can understand. Find the coordinates of any point on the curve where the gradient is the same as that. It's kind of the other way. We've already been given the gradient function. We've already given the tangent, right? We want to find the points at where that tangent is the right one. So this, I would rearrange this straight away to y equals 41 over 16x plus 6 over 16. Okay, just divide everything through by 16. Because then that is the gradient that I'm looking for. that is the gradient of this line, and I want to match that gradient with the gradient that I will get from here, and therefore find out the x values and therefore the coordinates that work. So let's work out the gradient. Here we go. Y dash equals power out front, lower the power by 1. Well, the 1 comes out front. This just becomes 2x. Oh, no, it doesn't. It just becomes 2, because that would really become x to the power of 0. X to the power of 0 is really just 1. Now, minus 1 over x. Didn't we already do the derivative for that here? That's handy, isn't it? So we already know the derivative is this. Minus 1 over x squared. So we've already got the derivative. That was handy. That was nice and easy. So I have the gradient function, and I have the gradient that I'm trying to get. So now what I do is I take this and I put it in there for y dash, because y dash is the gradient. This is the gradient function, and I want it to equal that. So I want it to equal 41 over 16 equals 2 minus 1 over x squared. Now if you're on your class pad, you can just go solve and you're away. But if you're not, let's see what we can do here. So if I put everything over a common denominator of 16, that way I can get rid of that 16, that'll be out the way. So 2 will actually become 32 over 16. 32 over 16 is still 2, isn't it, right? And this, won't this just become 16 over 16x squared? Now that's worked for me a little bit. Hasn't really worked for me fully, has it? No, I'm going to take a different direction on this. Right, bypass that. I'm going to take a different direction here. I was thinking that would work for me, but the x is on the bottom line here. What I am going to do is I'm going to move the 2 over to this side, okay? And I'm still going to make it 32 over 16. I'm still going to do that part. Move it over to here. Can you see if I move that over to here, it becomes negative. It'll be 42 minus 32, which would be 9. So I reckon it'll be 9 over 16, and it will be, no, it'll be positive. 9 over 16, and it will equal 1 over x squared, like that. Alright, so what did I do? I took this guy, moved him over to here, became 41 minus 32, there's my 9, divided by 16, and I was left with that guy there. So I think I'm okay there. Now, why don't I flip things up? This guy can come up to here, and that guy can come up to there. So couldn't I now write 9x squared equals minus 16, or x squared equals minus 16 over 9. Okay? Now if I take the square root of both sides, don't I end up with a bit of an issue here. Oh, I know where I've made a mistake. Look, follow back up here. Here we go. Look, this is okay. I thought I'd made a mistake here, and I have, because I can't take the square root of a negative. That's okay. I'll pick this up now. Here's the plus. That should have been a plus. That should have been a plus. That would then be a plus. This would then be plus. That would be plus. I'm okay now. All right? So I missed this. I thought it was going to be a negative. Oh, hang on. My question is falling apart here. Okay, this is okay. Here, this is what we do when we screw up. We come back and we start again. Let's start again. All right. I might have made a mistake. Hopefully I can resurrect this. Keep watching, or just cut this bit out, whichever. So, here we go. Let's take the derivative again. I might check the question. No, the question is correct. Okay. I'm a little lost. Here we go. Y dash equals 2 minus... I see where the issue is. I see. It's 2 minus brackets. Now that, right, not the negative part, that becomes that, becomes that. So it's negative over negative, right? Because the part I differentiated was 1 over x. 1 over x is equal to minus 1 over x squared, but it was minus 1 over x squared. So I actually was in the right spot. Why did I rub that out? That's okay. Let's go through again. So y dash would equal 2 plus 1 over x squared. And remember that I want the gradient to be this guy here. So that's going to slot in there. It's going to become 41 over 16 equals 2 plus 1 over x squared. Now I'm going to do the same thing I did before. I'm going to make this 2 into a 32 over 16. And in a similar way, I'm going to take that guy, move him over. I was doing everything right. I had one thing wrong. Move that guy over. He'll become 41 minus 32, which will become 9 over 16, equals 1 over x squared. That guy up to there, that guy up to there, that guy down to there. X squared will equal 16 over 9. Therefore, x will be the square root of 16 over 9. Now be careful, plus and minus here. We can go plus 4 over 3 or minus 4 over 3, I think. I think we can get both of those answers. Hopefully I got them right now. We'll see what we do. But now what does it ask for? Let's check. Find the coordinates. Now, I've run out of room here, but coordinates, right? What does that mean? Co means 2. Coordinates. So I'd have to take these answers, bring them back into here, and I'd have to find the point on that curve where the gradient is equal to this. So those two would have to come back into here. It'd be a little bit tricky, but we'd need to work it. ClassPad would get it for us, and then we'd be done. Sorry about that mistake, but I had made a mistake, but I kind of thought I'd fixed it. All good, all good. It's there, put them in, get the coordinates, and your answer's done. Thank you very much. Woo!